going to start taking classwork now. I think it's item you've understood a lot. So take B as your classwork, define it, find one of the ratio using calculator that is exact, and then from there use Pythagoras theorem to find the other side, and then you define the other ratio. Alright guys, example 3. Find the exact values of the 6 trigonometric functions of the real number t. Okay, so this is also circular form again, real number t. So if we draw the diagram out, voila, so we simply have this right angle triangle here neatly drawn, and then our theta is here. Okay, so this is x, 12 over 13, and this is y, 5 over 13. Okay, and then we can now use Pythagoras theorem. So let's call this place R. So by Pythagoras theorem, we have r squared equals to x squared plus y squared, which is 12 over 13 squared plus 5 over 13 squared, and that is 144 over 169 plus 25 over 169. So that would be 169 over 169, which is equals to 1. So therefore r squared equals to 1, r equals to square root of 1, so r equals to 1. So the radius is 1, and then we can now redraw a triangle with the radius as follows. So we have theta here, we have 12 over 13, we have 5 over 13, then we have 1. So the trigonometric ratios will basically be sine theta. Remember that actually here t equals to theta. Okay, so sine theta equal to opposite 5 over 13, which is y, cos theta equals to x, 12 over 13, tan theta equals to y over x, so 5 over 13 divided by 12 over 13, and that will simply be 5 over 13 multiplied by 13 over 12. So 13 cancel 13, and that will be 5 over 12. And then from there we can define the other three, taking their reciprocals. So therefore cosec theta equal to reciprocal of all that, so that is 13 over 5. Sec theta equals to 13 over 12, and cot theta equals to 12 over 5 respectively. So that is how you define that. Example 4. Find the 6 trigonometric function values of the specified angle. So we have this angle, we have all of the parameters. Let's draw it very well, and we can stand. So this is number 4. So we have hypotenuse is 0.5. So if beta is here and this is here, opposite is 0.3, adjacent is 0.4. Okay, so let's define the ratios. So therefore we have the sine beta equals to 0.3 over 0.5, so which is 3 over 5, multiplying both sides by 10, and as a result cosec beta will be equals to 5 over 3, right? Cos beta equals to 0.4 over 0.5, multiplying both sides by 10, that will be 4 over 5, and as a result sec beta will be equals to 5 over 4. So tan beta equal to opposite over adjacent 0.0 over 0.4, which is 3 over 4. And as a result of that, cos beta will be equals to 4 over 3. So these are the 6 trigonometric ratio. It's very easy. Just apply your formula, cosine, and so on. Alright guys, so we are going to take this one as your second class work, class work 2 in this lesson. So in the same way, find the 6 trigonometric function values of the specified angle. Okay, and example 6. Okay, so this should be our last example in this section. Given that beta equals to 2 root 3 over 3, cos sine beta is this, cos beta is this, and tan beta is this. Find cosec beta, sec beta, and cos beta. So it's very easy and simple. So let's write what we have. Sine beta is 2 root 3 over 3. 2 root 2 over 3. Cos beta. Cos beta is 1 over 3. Okay, and tan beta. Tan beta is 2 root 2 equals to 2 root 2. So we have to find other ratio. So from here we can find cosec beta as 3 all over 2 root 3. Okay, so sorry, that was root 2, not root 3. Okay, so that was root 2. So here we have to rationalize denominator because we can't leave the answer like that. So it is very also important in trigonometry that when your denominator is given as such, make sure you rationalize. Okay, so rationalizing denominator here, we have 3 root 2 all over 2 times 2, so which is 3 root 2 over 4. So therefore cosec beta equals to 3 root 2 over 4. And then we have sec beta. So sec beta equals to 3 over 1, which is simply equals to 3. And cot beta equals to 1 over 2 root 2. We have to rationalize times root 2 over root 2, which is root 2 over 2 times 2, which is root 2 over 4. And that is the answer. So this is how you can apply that and solve problems. Okay, so alright guys, so in this lesson we've looked at the 6 trigonometric functions defined in further mathematics: sine, cosine, tangent, secant, cosecant, and cotangent. So secant, cosecant, and cotangent are reciprocals of cosine, sine, and tangent respectively. And then we've looked at the unit circle approach, the circular approach, and the right triangle approach. And then we've solved so many examples on there on it. So do your classwork and make sure you submit. So in our next lesson we'll be looking at special angles. See you then.